Hey guys, I'm back with a new video. In this video, let us talk about how to measure similarity between clusters. Similarity between clusters. We have already learned in one of the previous videos that we can measure similarity between data points or data observations using the Euclidean distance. We also learnt about Euclidean distance in one of the previous videos and also used it in our implementation of the KNN algorithm. The link for the videos covering the same can be found down below. Now the main question here is that how we can measure the similarity between clusters, because these clusters contain a lot of data points. So let us see how we can measure similarity between clusters. Now in hierarchical clustering, we have the concept of something called as linkages. Now the concept of linkage in clusters is analogous to the concept of Euclidean distance in case of data points. Now using the concept of linkages, you can tell what type of similarity does the clusters have relative to each other. So let us see different types of linkages we have and how actually they calculate the similarity between clusters. So different types of linkages. Now basically we have 4 different types of linkages. First one is the complete linkage. Then the second one we have is the single linkage. Thirdly, we have the average linkage. And finally, we have the centroid linkage. So let us first talk about the complete linkage. Now in complete linkage, we have to calculate the pairwise distance between all the points that we have in all the clusters. Pairwise distance between all the points that we have in all the clusters. So let me demonstrate this with the help of a diagram. So let us say we have these 2 clusters. And say in the first cluster, we have these 2 points. And in the second cluster, we have these 2 points. Now here we need to calculate the pairwise distance between all the points that we have in all the clusters, right? So let us label these points like this: 1, 2, 3, and 4. So we need to take the pairwise distance between 1 and 3, between 1 and 4, 2 and 3, 2 and 4. And now here you can see we are having the 4 pairwise distances between the points that we are having in these 2 clusters, C1 and C2. Now here we need to store the maximum of these pairwise distances that we compute. So here you can see we have the pairwise distances 1, 3, 1, 4, 2, 3, and 2, 4, right? And let us say the maximum pairwise distance is this one, 4, 2, right? Let me use some other shade for this. So we will be storing this maximum pairwise distance between 2 and 4 as the linkage value for this case. So here we will have the linkage value. Let us denote this by L, and here we can store the distance 2, 4, which is the pairwise distance between the points 2 and 4. Right? So remember, this is the value of linkage when we make use of the concept of complete linkage. Then let us now move forward to the second type of linkage, which is known as single linkage. Let me clear this up first. Single linkage. So for complete linkage, as I just explained, for complete linkage, for our same diagram, which is this one, 1, 2, 3, and 4, the linkage value was maximum of the pairwise distances that we had, right? So you can say we selected the maximum out of the pairwise distances 1, 3, which we can denote by saying D13, D14, D23, and D24. And we assume that the maximum pairwise distance was between the points 2 and 4. So when we apply max on these, we get D24, right? So this was the linkage value for complete linkage. Now for single linkage, what we have to do is, so in the case of single linkage, we calculate the minimum of the pairwise distance between all the points of all the clusters. So we need to store the minimum value that we get from all the pairwise distances. So the linkage value in this case will be minimum of the pairwise distances. So let me denote this as PWD, pairwise distances, minimum of D13, D14, D23 and D24. Let us say the minimum pairwise distance is this one, so we get D23, right? So the linkage value in this case will be D23. Next we have the concept of average linkage. So let me clear the canvas first. Average linkage. Now let us use the same diagram again. So this is the cluster 1, cluster 2, point 1, point 2, point 3 and point 4. And here are our pairwise distances. Now for this case, we will be storing the average value of the pairwise distances that we compute. So we will take all the pairwise distances, we sum them up and divide this sum by 4. Because here we are having 4 pairwise distances, right? And this gives us the linkage value using the concept of average linkage. So the linkage value in this case will be D13 plus D14 plus D23 plus D24. And we divide this by the number of pairwise distances that we are having in this case, which is 4. So this is the linkage value in case of average linkage. Now also as a side note, these pairwise distances that we are computing, these ones, right, they are nothing but the Euclidean distances itself, because for pairwise distances we are taking data points, right? These are points and not clusters, and these are points that lie inside a cluster. So if you take distances between points, these distances or these pairwise distances are considered as Euclidean distances, right? But this linkage concept pertains to the clusters and not to the data points, right? So for pairwise distances, we are taking Euclidean distances between the data points in all the clusters. Now lastly, we have the centroid linkage. So if you have seen the previous videos on clustering, you must have gone through the concept of centroids. A centroid, as we know, is the mean or average of all the points that are present within the cluster. So let us discuss this now. Centroid linkage. So let us say that we again have the two clusters, C1 and C2, points 1, 2, 3 and 4. And these are our pairwise distances, 1, 3, 1, 4, 2, 3 and 2, 4. So for the first cluster, let us say our centroid is this point. Let me mark this using some other shade. Let us use orange for this one. And then for the second cluster, let us say our centroid is this point. So let me denote the second centroid by G2 and the first centroid by G1. So for the case of centroid linkage, we store the distance between these two centroids as the linkage value. So this distance. So the linkage value in this case will be the distance between the two centroids G1 and G2. Now we had discussed about agglomerative clustering in one of the previous videos. When the algorithm gets finished with the process of clustering of data point, we get a tree-like shaped structure, which is also called as a dendogram. And this tree-like structure helps us to understand the hierarchy between clusters. So now let us move forward and understand how we can create a dendogram before we interpret it. So let us take an example, understanding hierarchy between clusters. So let us take an example. Suppose we have this agglomerative clustering where we have two features, x1, say for example along the y-axis, and x2 feature along the x-axis. Now let us say we have a couple of points like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So we have 14 points in total. And now let us form the clusters using these points. So 1 and 2 form a cluster let us say, and then 4 and 5 forms another cluster. And here we are applying the concept of agglomerative clustering. So if you are not aware of the concept of agglomerative clustering, the link for the video explaining the same can be found down below. And then these two clusters we can combine to form one more cluster. So let us use the orange shade for this. This 3 point is outside this orange boundary, right? And now let us consider this 3 point as well, and then form a new cluster out of this. So here I'm using yellow shade for this. Next, let us form a cluster for points 10 and 11. Then with 14 and this cluster, let us form another cluster. Now with 12 and 13, let us form another cluster. And now let us combine these two clusters into its own cluster. Like this. Now let us combine 6 and 8 to form a new cluster. Then combine this cluster with this point 7 to form a new cluster. Like this. And finally, this cluster combines with this point 9 to form a new cluster. And then let us take these two clusters and form a new cluster out of it. So like this. And finally, this big cluster can be combined with this cluster to form the final cluster. So here I will need some more space. Let me erase this line that we had right below our heading. So let us combine this cluster and this cluster to form a bigger cluster. So this one, right? Now let us start creating a dendogram from this given example. So initially all our data points or data observations are represented as leaf nodes using these data points. So let me zoom this out. So let us start with the point that we labeled as 1, and this point gets clustered with the point that we labeled as 2. So 1 and 2, they combine to form a new cluster. So 1 and 2, and we combine them like this. Similarly, points 4 and 5, so 4 and 5, take them and combine them like this. Then let us take points 6 and 8, so let us say 6 and 8, and combine them to form a new cluster, which you can see here. Then 10 and 11, they combine to form a new cluster. So let me take this right here, 10 and 11, combine them and form a new cluster. 12 and 13 likewise also form clusters, so 12 and 13 like this. So here we are performing the initial steps of the agglomerative clustering, where all these individual data points are referred as individual clusters themselves. And as we keep on moving with our algorithm, each of these individual points, or more specifically single point clusters, they get merged with each other to form bigger clusters. Now in the next step, we merge the cluster that we form using points 6 and 8 with the single data point cluster represented using the point 7. So let us mark 7 here. This single data point cluster gets merged with the cluster that we form using the points 6 and 8, and we get a new cluster like this. So 6 and 8 forms a cluster, and this cluster combines with this single point cluster to form this cluster, right? Which lies right inside this yellow cluster, for which the formation we will see in just a minute. Then whatever new cluster we get, we merge it with a single data point represented by 9. So this cluster then combines with this point 9 to form this yellow cluster, right? So let us take the point 9 and then combine this entire cluster with this one to form our yellow cluster, which is this one. Next, we merge the clusters that we form from points 1, 2 and 4, 5. So 1, 2 represents a cluster, 4, 5 represents another cluster. We combine these two clusters to form this outer cluster containing these two clusters like this. Now we merge this new cluster with a single data point cluster 3, which is this 3 point as you can see here. So let me mark this right here. And then we take this and merge them. So this gives us a new cluster. Next we take the cluster that we formed out of the points 10 and 11, which is this one, and combine this cluster with the single data point cluster 14 to form this outer cluster that contains this cluster and this 14 point, right? So let us write down 14 here and combine this single data point cluster with the cluster that is formed using 10 and 11 data points like this. And now let us do this quickly for the entire dendrogram that we have. So the cluster that is formed using 12 and 13, this combines with the cluster which contains this cluster and this single data point. So these two clusters, this one and this one, these two combine to form this cluster, right? So let us combine them, and this is how we get this cluster, right? Now we need to combine this cluster and this cluster to form this cluster, right? So this yellow boundary cluster is represented by this. This orange boundary cluster is represented by this. And we need to combine these two to form this purple boundary cluster. So simple, we just have to do like this. And now what we need to do is, we need to combine this purple boundary cluster with this yellow boundary cluster to form this orange boundary cluster, which is our final cluster. So this entire thing is our purple boundary cluster and our yellow boundary cluster is this one. We combine these two clusters to form this orange boundary cluster like this. So this is the final dendrogram that we get as the result. So this gives us one big cluster. Now here's the question for you. Can you tell what points are more similar to each other? Are the points 10 and 13 more similar to each other, or are the points 11 and 12 more similar to each other? So 10 and 13 or 11 and 12? So pause the video for a minute and think about this. Comment down your answer below and then click to play. Okay, so let us discuss this now. So the answer for this question is that both these points or both these set of points are equally similar to each other. Let us understand the reason behind this. To determine the similarity between points, we just have to see the height at which the branches corresponding to these data points merge, right? Now the concept here is that higher the height at which the branches merge, that is the branches corresponding to data points merge in the dendrogram, lower is the similarity between the points. So do make a note of this. So if you see here the branches corresponding to 10, 10 and 13, they merge exactly at the same height at which the branches corresponding to 11 and 12 meet. So if you see 10 and 13, they are merging at this cut. So 13. And if you see for point 11 and 12, it goes right here, and the branch that is coming from point 12 also gets merged with the branch that is coming from 11 at this point, right? So you can say that points 10 and 13 are kind of equally similar to points 11 and 12. I hope this makes complete sense. Now as a side note, once you have the entire dendrogram, after performing the hierarchical clustering, you can cut your dendrogram at different heights. So suppose we make a cut at this height. we will get two clusters. So this purple boundary one and this yellow boundary one, right? If we cut the dendrogram at this height, so here we get two clusters. And if we cut the dendrogram at this height, we get this cluster and this cluster and this one as well. So three clusters we get if we cut at this height. So by performing these cuts, we are eliminating these merges that we did. So at different heights, we are able to visualize the clusters that we get, which is really a good thing. And here you can see we are exploring the dataset more thoroughly than what we did in case of k-means clustering. So this algorithm is a bit more advanced than the k-means clustering algorithm. Also, one thing to keep in mind here is that we are recursively forming clusters based on the similarity between them, using this linkage property that we discussed just a while back. Now, contrary to this, in the k-means clustering, we use the intra-cluster distance property to find the best clusters, which we had discussed in a video on k-means. So the link for the video on k-means clustering can be found down below in the description section of this video. So this was all I wanted to cover in this video. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, hit the bell icon to get the notification for all my upcoming uploads, and I will see you guys in the very next one.